My name is Kevin Kircher. I'm an assistant professor in the Department of Mechanical Engineering at Purdue University. So electrical components, things like power lines and transformers, all have limits to the amount of power that they can safely deliver. And so the more time that they spend kind of close to those safe limits, the sooner that they can fail and have to be replaced. So when a large number of electrical devices happen to be running at the same time, that can lead to a large spike in electricity demand, and that, of course, can lead to premature failure of some of these electrical components. So that can lead to high replacement costs and replacement delays, and ultimately utilities will pass those costs on to consumers in the form of higher electricity prices. So a lot of devices today, things like water heaters, air conditioners, heat pumps, refrigerators, operate in an on-off fashion. So an air conditioner, for example, will turn on when your home is too hot. It'll run for a while until your home reaches kind of a cool temperature, and then it'll turn off and let the home drift for a little while. So today, these on-off devices operate with essentially no awareness of their neighbors. So that can lead to unfortunate coincidences where a very large number of these devices happen to be on at the same time, and that causes a big spike in electricity demand. So in our research, we've shown that with just a little bit of communication and coordination, these devices can interleave their operation with their neighbors, and that can lead to substantial reductions in these electricity spikes. This technology could be applied at various scales. So for example, most homes have limits to the amount of current that they can safely tolerate in things like wires and electrical panels. So as we add more electrical devices to our homes, things like electric cars and trucks, electric heat pumps for space heating and cooling, we may find that our electrical demand kind of reaches or even exceeds the safe limits of that electrical service. So this technology could help interleave or coordinate the operation of those devices in order to keep current draw within those safe limits, and that could avoid costly upgrades to the tune of thousands of dollars and sometimes several months of delay to those electrical wiring and panel services. This technology could also be applied at larger scales, for example, a large apartment building or a residential neighborhood where you might have hundreds of devices all coordinating their operation.